Hello, welcome to the third presentation in the series Integrating the eTextbook Truly Interactive Textbooks for Computer Science Education. This series of presentations is part of C2Gen, a Chautauqua program for the 21st century. Today we'll talk about easy ways that you can contribute to OpenDSA. We'll talk about how we edit content, how we do translation support for different programming languages and written languages, and how you can make simple questions using the Khan Academy framework. So let's get started. Most contributions to the system come as content. Lots of people have worked on the content and contributed over time. This is an open source project, and the more people who get involved, the better. The first and easiest way that someone can contribute materials is to write prose. So when you look at an OpenDSA module, it has prose, maybe like this, as well as visualizations and exercises. Those are a little harder to do, so we'll start with the easy parts. So most content in OpenDSA is simply the prose that you see in the modules, and this is authored using something called restructured text, which is a so-called simple markup language. It's the language that the Python community developed to do documentation, and it has most typical types of authoring support you would expect for making documents. And so the best way I can tell you to take a look at how to do that is to see the documentation that the restructured text community has developed. And as you might expect, a lot of that is written in restructured text. There's the home page. One of the most useful things to look at is the Quick Restructured Text Guide, which tells you how the markups work for most things. Perhaps the best thing you can do is take a look at prose that we've written for OpenDSA. So this is an example of one module. This happens to be the guided tour module from the first presentation in this series. It's very simple. We've got some comments at the top. We've got something a little bit of metadata that tells about the module itself. We've got a title. We've got some text, subtitle. There are some links. There are some special directives in restructured text vocabulary. They call these things directives, but these are things that we wrote for the OpenDSA project to include code snippets, math, the slideshows. In OpenDSA module, there's typically slideshows and visualizations and exercises. So there's embedded slideshows, and then there's iframed slideshows and exercises. So that's pretty much it. Once you have a good sense for how the markup works, it's pretty simple to do. The second thing I want to talk about is two types of extensions or translation support. And the one is for different coding languages, and the other is for different written languages like English versus Spanish or Finnish. And so let's take a look. This is the GitHub repository, and what I want to point out is the structure that's used for the directories. And so this is the restructured text directory, and within that are different languages. And so in the English subdirectory are chapters, and within the chapters would be the text for the individual modules. And if instead you wanted to see what was available in, say, Finnish, well, there's not so many things. There's a merge sort module. I guess in Portuguese we have a couple of modules on algorithm analysis, and so on. So at this point we don't have a lot of translations, but the mechanism is pretty straightforward. You would simply make a copy of the file that you want to translate into the appropriate position in the directory structure in the language that you want. Then you would simply do your translation into the other language, and then when we configure, as we talked about in the second presentation, how to do configuration files, you can simply say to use the different language. So long as there are given files in that language, it will use them, and when it can't, it'll fall back to the English version. The other type of translation is for both coding languages and written languages within visualizations. And in that case, we use a JSON file to help structure things. And so let's look at the written language translation first. So your typical slideshow has, of course, images, and there's often a sentence or two that goes with each image in the slideshow. And then there may be things like a couple of buttons, like an About button or a Run button, and so on. You define all of these things as strings in the JSON file. And so notice the English translation has its own section. And then if you want to translate, say, into Finnish, then all you need to do is reproduce all of these tags and then put the translated version in this place. And so you just match all the tags. And then there's a Swedish version for this particular visualization as well. So you can see that's pretty easy. Now the other thing you can do is change the programming language. Assuming you have an implementation for the code snippet that you need. In this case, this is insertion sort. Then in the code block section, you name the language you want to use, and this is matched to a particular directory. So there's no special knowledge about what these languages are. It's just that there happens to be a directory in the right place called processing, so it knows to look there. And then this tells it particularly which file to look at. And within that file, it'll find some code lines that are bracketed by particular comments. And this identifies the comments. In the visualization that's showing the code snippet, you typically will highlight certain lines of code as the visualization goes along. Of course, in a simple version of Java, perhaps with no generics, you might have the signature block on, or the signature line would be the first line. And perhaps in C++, maybe you're doing it with templates, and maybe it takes 2 lines to define the signature. So you could specify different lines if you wanted. It so happens in this example, the line numbers are the same, but you could imagine that in different coding languages, you might need 2 lines for one thing in one language and 1 line in another language. And so each place that you want to highlight a given line or multiple lines, you give it an identifier, and then you just state what the line numbers are. We do this for each of the coding languages. Now, in this example, it was very simple code, and the line numbers are the same for all 3 examples, but it doesn't need to be. And the next thing I want to talk about is the Khan Academy framework. So the exercise framework gives us a very rich mechanism for creating exercises. The virtue of this is how flexible it is. The downside is it's a lot like programming, which if you don't like to program, you might find to be a problem. But the format for the simple exercises is pretty simple, pretty straightforward. You can pretty well copy one and just change some words and get your new exercise without too much trouble if you chose a good example to start with. Let me talk just a moment about the general mechanism. Then we'll show simple examples that are easy for anyone to pick up. But I want you to get some sense of just how flexible this system is and how powerful it is. You can do pretty much anything you can imagine, provided you can imagine how to do the following 4 things. First, you have to have some mechanism for generating a problem instance. If all you want to do is give down a statement, you say, what is 2 plus 2, and that's all your question is going to be, then the problem instance is simply that text, and there aren't any choices. But if you wanted to be able to say what is, and then you had a 2-digit number plus another 2-digit number, then you would have to write a little bit of code to generate 2 random 2-digit numbers to put into the sentence. And the system will let you do either one of those. So as long as you can imagine a way to generate your question, then that's the first of the 4 things you have to do. You have to generate the question. The next thing you have to be able to do is, given the problem instance, you have to be able to generate the right answer. Now, if the question is, what is 2 plus 2, then your model answer is just 4. You may give some multiple choice alternatives, 1 and 3 and 7 perhaps. And it's pretty straightforward. But if you wanted to be able to generate an addition problem of arbitrary two-digit numbers, then you have to compute the answer for those two-digit numbers. If you would like your exercise to be show me how to do insertion sort on this set of numbers, then you would have to generate a random set of numbers, and you'd have to then run your own algorithm over that to generate the right order. That would be your model answer, would be the sorted order for your numbers. The third thing you have to do is provide a user interface. Now, if it's simple things like a multiple choice question or a true-false question, the Khan Academy framework can do that automatically for you very easily. If it's something custom, like I have an array and I would like to be able to swap things around in it to be able to show how to do a sorting algorithm, then you would have to write the interface to do that, and you'll see that many OpenDSA exercises use our JSAV library for describing and presenting the data structure to manipulate. And the final thing you need is to take the student answer that was generated by the student using the interface and compare that to the model answer that you generated and decide whether that student answer matches the model answer. And if it does, then the student would be given credit, and if it doesn't, they'd be told it was incorrect. And if you can do those four things, anything that you can do those four things for, you can write an exercise for. That can be very complicated, but in a lot of cases it's very simple. You can go a long way with very simple multiple choice and true-false type questions. So let's see a couple of simple examples. So here is a very straightforward multiple choice question. There's simply some text and there are some choices, and the framework is pretty good about a lot of options, like it'll randomly put these in the right order, and there's a lot of options for deciding how many distractors to put in and whether you will always put in the right answer or sometimes whether you'll put in none of the above, and so on. So there's a lot of flexibility in that, even if it is a static multiple choice question. Static in the sense that the text of the question never changes, and so the answer never changes. And the source for this is got some boilerplate around it. A lot of this never changes, but basically you will state your question and you'll state the solution text, and then you'll show the distractors, and you might give some hints, and the system will take that and give it back to you in the right format. Another example has what looks to be simple text with simple multiple choices. There's a very minor wrinkle to this, and that is that in the text we have some variation on what exactly the student will see. Now, in this particular version, there's no meaning to this variation. The answer is the same, whether the question asks for best or whether the question asks for average or whether it asks for worst. This is simply, you could say, sugarcoating, but it adds a little more variety to the question. But in this case, the answer is the same, regardless of exactly how that question is stated. Here is an example of a question where there are some choices and then there's none of the above. And it may be that none of these choices are correct. It may be that one of these choices is correct. And when we look at the source, what we have here is a correct answer, and we have several variations. In one of these variations, there's actually a little bit of range. This is actually a random number generator, so some variation can take place based on that random number. And then there's a limit to how many choices will be given. In this case, there's none of the above. It's because that's on, it's true. And then there's 4 choices, one of which will always be none of the above. And we have several options. Basically, it will pick at random from its choices of 1, 2, 3, 4, 5, 6 things. So you'll see 4 of the 6 things. There's always a right answer, because the right answer will be the right answer when it's given, and it'll be none of the above when it's not given. So again, more flexibility, more mileage to get out of your question. Now, the way we write our questions is that we have one file for each question, and then if we want to sort of connect them together into a series of different questions, so you can be you can answer a question, then you'll be given a different question, and you'll be given another question. Well, we can control that with what we'll call a summary question, which is very simple. It's simply a question that references other questions, and so it will pick from these at random. And if you have a reason why you want one to come up more often than the others, you can set weights for them. Here is a question that has a little bit of computation to it. And in particular, the question that the student gets has some variation here. And in this case, the variation isn't just meaningless variation. Depending on exactly what phrasing it uses, will change the proper answer. So let's see how that works. So first, we're introduced to some variables. And so some of the variables are choices in string to be presented in the question. Some of them are random numbers to decide which string we're going to use. And then the values of those random numbers will also be used basically to check a lookup table to see what the right answer is. And then, of course, these strings here are variables themselves. If the 0th position in the lookup table is this word linear, which translates into the string linear index, and essentially what happens is we have 2 choices for 3 things. So there's 8 choices, which can be computed to one of these 8 choices for the right answers. And so we flip our coin for each of these values, and it generates a string. Based on that, you'll pick one of these answers. And then the model answer is that position in the table based on the 3 random numbers. And then the match is simply, did the student answer give you, did they select the same string as is the model answer string for that question? So this is an example of a fill in the blank. And in this case, there is also some computation for the model answer. So there's some random number generator to pick some choices here about the conditions to the question. We look at the source. We have a constrained random number for one of these parameters and a constrained random number for another one of the parameters. And then we have a mechanism for generating the right answer from that. And so we can generate our random numbers, which in turn generate the values that go into the question as it's asked, and then those same numbers are used to compute the proper answer. The student types in a number, and then that number is compared to the model answer to see if they got it correct. Here's an example of using our JSAV visualization library to generate a data structure that goes on here. This one's pretty simple. We're not using this as part of a user interface. It's just a static picture that the student sees. Now, in this example, it'll always be the same tree, but one could generate this tree with random numbers if one wanted to. But nonetheless, there's no user interface in the sense of the user, say, changing the order of these things like there is in some of the exercises. In this case, the user interface is simply that the user types a number, and we compare that number against our computed number. In this case, the source is that there is a JavaScript series of very simple commands. This is a pretty simple-minded question. We simply generate a static image by hard-coding, put 2 into the left of the root. Root's 14, 2 goes to the left, 1 goes to the left of the left, and so on. So we just simply hard-code all the positioning using JSAV commands. Again, the answer is hard-coded for this question, so one could come up with a question that randomly generates a tree of varying depths and computes the depth of the tree, and so one would have a much richer question. But in this case, we chose to do a very straightforward version with a static tree and a static question. So that introduces our tour to simple Khan Academy exercise questions inside the OpenDSA system. And I'll point out that while we use a custom version of the Khan Academy framework, the files that we generate to use are just straight Khan Academy framework files, which could be used. They could take and use them if they wanted to. These files work the same as the questions they use for their site. That's it for today. Thank you for listening.